Hey guys, so I wanted to go ahead and do a review over the Unit 1 PowerPoint that I posted. I posted a review for Unit 1 it's a collection of reviews that the Facebook group that I'm in has organized. It's just teachers around the country that are making their own reviews. This is separate from the College Board reviews that you can access through the link I have on my Instagram under the bio, and that's the College Board reviews. And then you can also use these teacher reviews that are posting that I'm going to post for you guys. And then you can also use my reviews if you would like, as well as all those sheets that I put in the modules that are really good, like one-page reference. Again, I would print all those out, have them in a binder just to look at really quickly on the exam. So if you can tell it's a topic on transcription and you're a little bit rusty, you can go look at your notes really quick and know where they are. So before you take the AP exam, I definitely recommend being highly organized, that you know exactly where everything is and that you can reference it really quick to give you just a quick boost of knowledge before you start answering the question, because 25 minutes really isn't very long to answer it. So I'm going to go through this with you guys real fast. It's on Unit 1. So this is after experimental design. Experimental design is enclosed or encapsulated within the science practices of AP Bio. And remember, your first FRQ will be on experimental design, so it's super important. But when they incorporate concepts, they could come from any of the units 1 through 6. So that's why we're going to go over the topics as well. So I need to put this in. Okay, so if you guys remember, we have different types of chemical bonds. Covalent bond is when the two different elements are sharing electrons, and it's going to benefit both of them because they're both able to get the full octet. Remember, if they're sharing equally, it's nonpolar, so they're just like perfectly sharing electrons. And then a polar covalent bond is when there's an unequal sharing of electrons. And so if they're perfectly sharing, they're both pulling electrons equally, and they have the same charge. But if there's a polar covalent bond, then one is pulling electrons towards it, and it's going to then, because it's more strongly pulling the negatively charged particle towards it, it's going to take on a partial negative charge. And then the one that's losing electrons is going to have a partial positive charge. The electrons haven't been completely transferred from one element to another, and so it's not considered an ionic bond because there's no transfer of electrons. We're still sharing, it's just sharing unequally. So I always like to relate this to like a tug of war for electrons. If you have two equally sized, equally strong people pulling on each end of the rope, there's really not going to be a big, there's not going to be a big lean in the tug of war, right? They're probably going to just be kind of standing still, holding, pulling, and there's not going to be a huge discrepancy in where the electrons or the rope goes. But if you have like a 15-year-old and a 1-year-old, the one that pulls more strongly is going to get the electrons, and then the little 1-year-old will be hanging on for dear life, so they still have access to the electrons, so they haven't completely transferred the electrons. But they're just losing them to the one that's stronger. And so the one that's stronger is going to have the negatively charged particle surrounding it, taking on a partial negative charge, and the one that's losing electrons slightly is going to have the partial positive charge. Ionic bond is an actual transfer of electrons. So that has to do with when one is like, hey, I have an extra electron in my outer shell that I really don't want because it's easier for me to just ditch one than gain 7. So I'm just going to get rid of this electron. And so when they lose an electron, they become a positively charged particle. Then there's another element that's like, hey, I have 7 valence electrons. I would really love to have one. And something like sodium's like, great, I had this extra I didn't want. I'm going to toss it out. And then something like chloride or chlorine is like, oh, that will be great. I'm going to grab that. And when they get an electron, they become a negatively charged particle. So there's an actual transfer of electrons, and it's like beneficial for both. Like sodium's like, I didn't want it, I have an extra, and it's don't feel like getting 7 more, so I'm just going to ditch one. And so I'm positive now. And then chlorine, sorry, I always get that wrong. Chlorine's like, hey, I have 7 in my outer shell. I'd be so happy if I just had one more. And so they pick up that extra electron and like, now I'm negative. And then because one's positive and one's negative, they attract and form an ionic bond. And that's when you form the cation, which is our positive charge particle, and then our anion, which is our negatively charged particle, and then they come together in an ionic bond. And then a hydrogen bond is just a bond between, it can be between hydrogen and fluorine, oxygen, and nitrogen. Remember, hydrogen bonding is fun. Typically, it's between hydrogen and oxygen when you have two water molecules that are bound together. So I have these silly little painted rocks at my disposal right now, so I'm going to use these. This is my ladybug. And this was supposed to be an Easter egg. It was a total fail. I used washable paint on rocks, and then it rained. Whoops. Okay, so if this is a water molecule, it's held together by a polar covalent bond between oxygen and hydrogen. And this is a water molecule that's held together by a polar covalent bond. Both are partially charged, so they have like positive and negative pole. And then they're going to be attracted to each other, where the positive hydrogen of one bonds to the negative oxygen of another, and they form a weak bond, which is why we get all the properties of water that we do. So hydrogen bonding is really important. It's between, this is a water molecule, this is a water molecule. They have a weak bond in between the water molecules. It can be broken. It's not, I'm not going to be able to break the bond within a water molecule, which is that polar covalent bond. So like, I can't break this rock in half because that bond, the polar covalent bond, is very strong within the water molecule. But there is the weak bond of the hydrogen bond that forms between them, which is what creates like surface tension. And you can break surface tension, or cohesion. When you have a droplet of water, you can bust that little droplet of water. So hydrogen bonding is weaker than covalent bonding and ionic bonding, but it's still important for the properties of water. Okay, electronegativity is how strongly something attracts electrons. So the more electronegative it is, the stronger it's going to be at its pull of electrons. So when I gave the example of tug of war, the oxygen is much more electronegative. It's going to pull the electrons towards it. And remember, the electronegativity of oxygen is why it's able to pull electrons through the electron transport chain for us to even have cellular respiration, the electron transport chain, chemiosmosis, ATP synthesis. All that stuff is because oxygen pulls electrons through the electron transport chain, which allows us to pump hydrogen ions across the membrane and then come back through ATP synthase. And so if it weren't for oxygen being so highly attracted to electrons, we wouldn't have a lot of the property of life that we do. So oxygen being highly electronegative is why water is polar, and it's also why we use it as our final electron acceptor in cellular respiration. So it's important. Three most electronegative elements. You can look in the top right corner of the periodic table. I know oxygen's in there. I think fluorine is the most electronegative, and nitrogen's probably one, which is probably why hydrogen bonding happens with fluorine, oxygen, and nitrogen. Don't quote me on that. I'm just going by my memory, but check that one. It's going to affect ionic and covalent bonding. We kind of already talked about that. The covalent bonding, it's going to cause the polar covalent bond. And hydrogen bonding is because the polar covalent bond, it's going to cause the hydrogen bond to occur between two partially charged molecules. Water is polar because oxygen's highly electronegative. It pulls the electrons towards it. So if we're looking down here, oxygen's large. It's going to be able to pull harder on that tug of war. It's going to be able to have more attractive force of the electrons. It's going to have a partial negative. Hydrogen's going to have a partial positive. And that's why they are polar, because they have a positive and a negative on both sides of the molecule, or on either side of the molecule. So yes, hydrogen's partially positive, oxygen's partially negative. What does this say? Okay, so if I were to draw another one, I can't draw on a PowerPoint screen for whatever reason. But remember, this is like what we did on the door to the stock room, where you made a water molecule, your person next to you made a water molecule, and then you just put the little, sorry, my neighbor yelling. You put one negatively charged oxygen next to the positively charged hydrogen. So if I were to draw another little Mickey Mouse looking thing, I would put the oxygen next to the hydrogen, because the partial positive would attract the partial negative. Right. Okay. Cohesion. I'm not going to spend too much longer on the properties of water, because although it's super important, it's just like you probably know it by now. Cohesion is water sticking to another water molecule. It's because of hydrogen bond. It's important for life on Earth because it creates little water droplets and things like that, and allows for things like transpiration to occur in plants, where water travels up the plants, Water sticking to water is how it's able to climb up the plant. Adhesion is water sticking to other surfaces. That's important because, again, transpiration is when water goes up the trees of plant, or up the, like the vessels of plants, from the roots to the leaves so that photosynthesis can occur. And adhesion is why it's able to stick to the inside. Surface tension is what causes the film water, like at the top. So it's similar to cohesion, where water molecules are sticking together, but specifically happens at the surface of water. And this is important because insects and different things can walk on the surface of water and survive by not breaking the surface tension. High heat capacity, typically people know the first three and kind of get confused on the last two. Woo. High heat capacity means that water can absorb a lot of heat before changing temperature, or absorb a lot of energy before changing temperature.
Are you talking to my friends, Mommy?
I'm not talking to your friends' mommies. I'm talking to my students. You want to say hi? Hi? Okay. I'll be right in. You good? Sorry, guys. Okay, so that means it takes a lot of energy for water to get hotter, and it takes a lot of energy for water to get colder, which is why you go to the beach. What, honey? You want water? I got you apple juice. Okay, I'll be in there in a minute. If you go to the beach in January and it's like a hot day, the water's not going to be hot yet because it's cold. And it takes a lot of energy for it actually to heat up. So it's not until like midsummer in Florida, when we've had a lot of hot days, that you're actually going to feel the water actually change temperature. Also, when you're heating a pot of water to boil, the metal has a lower heat capacity, or high specific heat, or just specific heat. So the metal is going to get hot faster, and then the water is going to take longer because water has a very high specific heat. This is good for our bodies because that means that because we're like 70% water, we're not going to walk outside and immediately change temperature based on what the ambient temperature is. So that's how we're able to thermoregulate. We're called endotherms, warm-blooded, because water is able to regulate temperature in our body, and it takes a lot of energy to change the temperature of our body, which means that we aren't affected by the temperature of the air. So we're not like a lizard trying to lay on a rock to get warm. We are able to regulate using the water in our body and things like that, and obviously different things that help. Expansion upon freezing. The hydrogen bonds are going to create this like lattice, which causes the molecules to expand. And so when water expands upon freezing, it gets less dense, because as we increase our volume, our density goes down. And so as it goes, the volume goes up because it gets larger, the density goes down, so it becomes less dense than liquid water, and it's able to float. And so because ice floats on water, because it expands when frozen, that is why sea life, aquatic life, is able to survive underneath the ice during the winter. This freezing on top creates like a layer of insulation, and that's able to keep the animals alive underneath. And if it just sunk, then our oceans would just freeze and everything in it would die. And then when it warmed up, then everything would be dead, and that would be bad. Remember, acidic means they have a high concentration of protons, and that the pH is low. Basic means you have a high concentration of hydroxide and the pH is high, above 7. Neutral is 7. pH is determined by taking the negative log of the hydrogen concentration. So on your calculator, you would hit the negative button, the log button, and then you would use the hydrogen concentration. And you guys probably don't need to calculate pH, but those are good things to know. Okay, so that was properties of water. I'm going to stop right here so that you take a little break. And then I'll make another video in just a second of organic and the macromolecules versus whatever. So that is what I'll do in just a second. So I'm going to stop here. And then if you want to go to the carbon and or macromolecules video, then click on it.